Okay, so you heard these people. How important is filament drying? And I realized the importance of filament drying is when in my last video when I tested the agriculture wire, which is made up of PET bottles, and it didn't really print, so I used my heat bed to dry that filament and then print it, and then I got quite a good result, but not that good. But then I realized I need a filament dryer, so I went online, scrolled all the websites, I found Eason, Appleton, I don't know, a hell of a lot of company which manufacture 3D printers, so they manufacture filament dryer also. But then there's like inside me, there's a thing called DIY spirit, or I don't know what exactly the name is of that kind of spirit. And then I realized actually I think I need to make my own filament dryer because I have to like satisfy that DIY spirit. And then I started working. I opened one of the magical tool called Fusion 360. And then I started designing, and I also took the help of ChatGPT regarding the science behind the filament dryer, understanding every single thing, how this works. Then I thought I want not just me, but every person out there to think of its own, to feel this, to satisfy that animal or instinct inside of being a DIYer or whatever you want to call it, a person who makes everything by himself. So I want everybody to have access of that. So I designed this filament dryer in a way so that everybody can make it by themselves and print it. So let's begin.
Okay, so before we start, we need some things in order to make this project, or you can say filament dryer. So first thing is, let me just remove this invoice. So yeah, first thing we need is some spool of PETG. Well, our beloved PLA is really awesome filament, I would say, and it's one of the best filament. Like PLA is so easy to print and easy to print. That's the best thing about PLA, nothing else. Thing is, we're gonna need PETG because it's now there's like heat is involved in this process, especially in the filament dryer. So we need some material like PETG. Well, you can try with the EBS too, but the problem is printing EBS in a bed slinger. It's kind of hard, warping and all. There's a lot of problem with the EBS. So I would say go with the PETG. So I'm going with the CR series PETG. So I got two spools of this thing. One is black, one is red. So that just looks beautiful. And then, well, there are a few other things too that needed to be get. Next thing we have is these blower fans. It's a 50-15 blower fan, I believe. And these will be used to spread the heat in our whole enclosure of our filament dryer. And then we need few other stuff like this thing. It's a humidity sensor and as well as the temperature sensor. So this will be our indicator to check the humidity inside the filament dryer as well as the temperature. And then the other thing we need is like one of the most important thing, which I already opened actually. So this is XYJ02 relay module. So basically we're gonna set the timer on this thing, and after that timer we're gonna break the current flow to the heater, and that's how you can set the timer of your filament dryer using this cheap relay module, which is very useful. So I would recommend get this one too. One of the main component that you need is this W1209 temperature controller, which is really necessary if you want to control the temperature of your filament dryer. So this is necessary. I'm going to use W1209 temperature controller, and this is gonna give me a control up to 110 degrees Celsius. So I recommend this one as filament dryer don't need much higher temperature, so you can go with that.
So before we move ahead, let me tell you, it took like in total of 30 hours of printing. But here's the catch, why it took 30 hours of printing. So if you go with the default 0.4mm nozzle, it will gonna take you at least 60 to 80 hours of printing. Well, I haven't calculated, but I come up with a rough number. But I use 0.6mm nozzle instead of wait a second. So 0.4mm nozzle. So I use 0.6mm nozzle. And the best thing about this thing is I went with a single wall 15% infill. By that I save, you not save the filament basically. If you print with a 0.4mm nozzle, you're gonna save the filament. But with 0.6mm nozzle, it's gonna require a little bit more filament, but it would be faster. So I have to record this video and upload it. And I don't want to waste any time, so I went with 0.6mm nozzle with single wall. That wouldn't be a problem except for the infill kinda reflect towards the outer wall if you go with a single wall. So that's the only problem, but I kind of like the design on the wall of Xyroid infill. But for the viewers who are watching, you don't have any constraint of time like I do, and if you have to went with the 0.6 or 0.8 millimeter nozzle, like except few prints that you have to do with the 0.4 millimeter size, because it requires a little bit more precision in order to work, just like thread. So for these are like thread is a spool holder basically divided in two halves, so you're gonna put it like this. So I'm gonna show you the assembly, then you can understand it properly. So like these things you have to print with 0.4 millimeter nozzle, because these have like threads in order to screw it together, something like this. So if you went with 0.8, 0.6 millimeter nozzle, in my experience, it will not gonna work. So be aware about that. So that's what I have to share now. Let's go to the assembly process, assemble the whole machine. So let's begin. Just in case if you're wondering how much filament it took for me to print all the parts that can be 3D printed, so almost took like the whole of this black filament except few like single digit gram left, and couples of gram of this red filament is left. So that's it. These are Creality filament. I think these are best in the market at a very good price, so check them out if you want to. It's not a sponsor video, I'm just saying. So these are all the parts, you can say it like it's a lot of parts. And if you're wondering what the dimension is, so it's a cube dimension, basically 300 into 300 millimeter. That's why I have to print it in parts, so that can fit on an average guys printers like with a build volume of 220 into 220 into 250 millimeters, basically a Ender 3 or something like that. So now we have to stick all these parts together like these one. Well, it's not that complex. You just have to, you need a proper stable hand in order to stick them well together. And for that thing, I'm gonna use this super glue. It's a Vega Quick or whatever you have available at your local hardware store. I'm gonna use this super glue, but with this also, I'm gonna use this silicone seal so that I can cover all the gaps on the every connection that I'm making here, so that no moisture can enter into this filament dryer. So we're gonna use this silicone sealant for that purpose. Well, I bought it for my aquarium, but I'm gonna use on this thing. So let's do it. So first thing we're gonna do is to assemble the whole build plate. And if you wonder what that imposter is, the red color, well, I ran out of black filament, so I went with the red one. That's not the problem. And so we're gonna use this 3 into 20 millimeter nuts and bolts. Well, if you can also go with the 3 into 15 millimeter. That wouldn't be a problem, but that's a minimum size. Below that, it's not gonna fit. So let's do it. Okay, so you can see it's a 300 into 300 millimeter base, and it's done. I put it together. If there's some spacing like this, if let's say with your print there's some warping happen or anything like that, so you can fill it with the silicone sealant. That would be much better and easier, and so that the moisture cannot enter in your print. And it is super strong. I've given like 3 holes, to put the screw. I've only used 2. I only filled 2 of them, so that wouldn't be a problem, and it's super strong. So I don't think you need to put like super glue now, because it is strong and won't cause any problem. Now it's time to go upwards and build it. So before sticking the rooftop on top of here, so we have to put some permanent things so it won't cause any problem. So if I stick it like this, then also I can like do all the work, but I want to do it like these are permanent things that I have to put it like these pads that I'm gonna put it down here so that it have more stability. And here you can see I've given little bit space, so if you don't want this thing to slip, you can put these furniture pads
and it's of like 20 millimeter furniture pads. Here you can stick it and then you can put it like this. So let's just assemble these things, and for this you need a 5 millimeter nuts and bolt. Well, after installing these foot or whatever you want to call it, it became more stable. But the thing is, you can do one more thing. Like I've given this space, you can see as here. So you can put like 3 into 20 millimeter round furniture pad, which will make it slip free. So what happened is now it's slipping, but after that it won't slip. So you can do that. I'm gonna do that, but I have to order it and then put it here. So it's gonna take time. So I'm gonna do it afterwards. It's not that necessary for me as of now. So now it's time to put the roof, but before that, still not the time to put the roof. On top of that, we're gonna use this heat pad. So you can go with the aluminum one, that will be far much better option, but I'm going with this PCB one, which I bought like 3 years back. So I'm using this one as it was a spare part just sitting in my cupboard. So I'm gonna use this one, but you can use the aluminum one, which is far more better than this one. So So we have fully assembled the main body, we have installed the PCB. I used these silicone one. You can use the spring if you want to. And these are the vents for the air. So it's gonna be super hot here, like the heat pad gonna be like 80 degrees Celsius or whatever temperature is it. So it can flow the heat, like here will be hotter here. So what it's gonna do, we're gonna put the blower fan here. That we're gonna do it like little afterwards, after we put the gate here also. And that gonna flow the air through these vents on the upper part of this chamber. So it's gonna create a proper distribution of the heat inside the whole chamber. That's what the idea is behind this vent system. So but before we put the blower on two sides, that will be a 50-15 blower. We're gonna put these doors here first thing. So let me just stick all of these things together and show it to you. I finally assembled the whole door or whatever you want to call it, and you can shut it down like this, and it's looking beautiful. And then I gave you locking cap. So what you're gonna do is you're gonna take this thing like this, and then you're gonna screw it. I'll show you afterwards. So this is the whole door, and I gave you two pockets. In these pockets you can put the packs of silica gel if you want to, for the extra moisture absorption. Well, it's optional, don't really need that, but I still gave you the option if you want to do so. Use it as a dry box instead of filament dryer if you want to. Well, you can dry your filament in these, and then you can use it as a dry box. Here you can see I gave you 3 holes in which you can put a PTFE tube that you can connect to your 3D printer directly, so that there is 0 chances of your exposed filament getting moisturized. So you can do that. So I gave you 3 holes to use it as a filament dry box too. And inside this you need 2 50-15 blower fans, so that it can take the hot air from nearby the heat bed through this pipeline or whatever you want to call it, and exit it through the air vents on the top, so it can make sure the evenly distribution of the heat in this whole chamber. So on the other side, now it's all assembled. Now only thing left is this wiring that we got to do. Okay, so let's start with the wiring. So you can see it's a 12 volt 10 amp power supply, JZ801 module, which is a timer relay, and then we have W1209 for temperature controller, 12 volt heat bed. Mainly works with the 12 volt heat bed, so go with this because it will not gonna support 24 volt heat and 24 volts
heat bed. So go with 12 volts heat bed. And then we have our two lovely, small, cute blower fans. So let's start with the wiring. So before that, let me state few things clear. So the red one will be used for a positive terminal and the black one will be used for negative terminal. So keep that thing in mind. And I'm supposing that you already did the AC wiring here, so we are not gonna go with the AC thing, but we're gonna focus on the main wiring. So let's start with that. So first thing what we're gonna do is to connect the positive terminal of our power supply to 6 to 30 volt terminal of JZ801, and then connect the negative terminal of our power supply to the GND, which is ground terminal of JZ801. Then connect the NO, which is normally open terminal of this JZ801 to 12 plus volt terminal of W1209 right here. Then connect the COM, which is common terminal of JZ801 timer relay to the positive terminal of the power supply, and then connect the ground terminal GND, or you can say ground terminal of W1209 to the negative terminal of power supply. Then connect the K0 terminal of this to the positive terminal of the heat bed, and then connect the negative terminal of the heat bed to the negative terminal of the power supply, and then connect the K1 terminal of our W1209 to the positive terminal of our power supply. Now there you go. So we have connected these things together. Now it's time for blower fan. So what we're gonna do is to connect the negative wire, which is black, of the blower fans together, and after connecting those wires you can take that to negative terminal of the power supply, and then connect the positive wire together of our blower fans. And then what we're gonna do, you're gonna take those positive wire and connect it to the normally open terminal of our JZ801, just like we did with W1209, because it's gonna control the current flow, or you could say it's gonna make or break the circuit of our whole wiring. So that's it, there you go. So we have finally done the whole wiring. You can follow this tutorial, or if you want you can rewatch this, because I know it's looking quite complex and quite messy right here. So but if you want, like you are finding it really messy, so I've given in the so you can check out the description below. I've given everything, all the wiring step by step in text form.
Okay, so I assembled every single thing as you can see, and I added two knobs over here so you can lock it properly if there's a like imbalance or it is not properly aligning, by the way. And these are better for sealing this whole thing from here, so that there will be no space for the moisture to enter inside the filament dryer. And I've been like put this thing with the four spools inside. That's the magic that happened, a mistake. Let me just show it to you, but it's showing 47% moisture at 24.8 degrees Celsius. But here's the most complex and exciting things is at the back. Oh, so it's kind of heavy. Sorry for the messy desk. It's just when you work, you have to test, and there's a lot of cut wire. So there you go. You have the wiring. So here is our JZ801 timer setter, or you can say relay, timer relay, and then we have this temperature control right here, and then there's a plug, and this is the power supply. You can cover this wiring with anything you want to, with the tape, or you can just cover it whichever you want to. It will not gonna cause any problem. So this is the back side of this thing. It might not look that good, but I think this is awesome. So yeah, you can see these are the case for every single module right here with the small little buttons, as you can see, and it is very smooth to press. But the magic is inside. Let me just show it to you inside. So I've given this knobs which you can rotate like this and open it easily. And after opening the knob, you can slide it down like this, and you can see here is our sensor. And then you can see, well, I designed this thing for like 3 spools of filament, and I've given like 3 holes right here, so you can take out the filament from here and without keeping it inside the box, so that it won't gonna moisturize again. But now I can literally fit 4 spools of filament. Now they are like very tight, so you cannot use it as a dry box. But if you are using like 3 filament, then it is super convenient. There's enough space between every single filament. But if you're drying, let's say 4, it's gonna reduce the efficiency of this thing and gonna take more time. But yes, you can keep the 4 filament, or you can dry the 4 spools of filament at the same time. So that's the very best thing, and that's like a really good mistake. But I would recommend go with a 3. But for the sake of the title, I'm gonna write 4 filament. So that's a really beautiful thing right here. And this is a heat bed. All the wiring is done. And yeah, one more thing, if you're putting 4 spools of filament inside. One problem that is here, I don't know whether you're able to see this or not. It's quite dusty filament there because this spool of filament has been kept out for a while. But you can see the vents are got little bit covered from here, but still there's like enough space so that the air can flow in the uppermost part of the chamber, so it won't cause you any problem. So yeah, this is the beautiful filament dryer. Now it's time to do some test run, and for that the best filament would be this PET filament right here, because if you watched the last video, you know the reason why this is the best, because it's agriculture wire that has never been kept in a sealed packaging. Well, this I got from a new supplier, so to say, so this one might looks better. So we're gonna test this one. We're gonna keep this much filament inside this filament dryer, and then we're gonna test how the print quality gonna be, whether it's gonna be good or not. You can check out the last video if you want to know about more this agriculture wire and how you can use it for 3D printing purposes. So let's just do it. Now it's time to learn some setup, which is quite complex, but once you learn it, it is frankly very easy. So the first thing is, let's go with the button. So this is S, which I marked as S is a stop button, then there is a set button, then up and down button. So what you have to do is to click on set button and hold it for a while, and you have to select many modes are in this. So there's P-4, P1.1, 1.2, 1.3, 4, 2.1, 2.2, 3.1, 3.2. You have to go with P3.2. Once that, you have to go with the open loop, and here you can set the timer, like how long you want this to be run. So in open loop, you can set the timer, and remember one thing, there's a dot like after every number. So this one is like all the seconds. So let's say 0 to 4 seconds, then it's 2.4 minutes, and then it is 0 minutes and all. So let me just show you to how this works. So basically, if I set this thing, now this is 111 minutes right here. So this is 111 minutes, so there is no R digit, so you have to first convert the hours into minutes, then you can set this thing up. So like you're saying, I'm going to 6 hour because I want my filament to dry for like 6 hours. For that, I have to go with 360 minutes. So right here, you can say 360 minutes. Once you've done that, click on set button, then you have the CL, which is closed loop. So now here you can set the how long you want this thing to be repeat this process. Like once it done 6 hours, then after like 6 seconds it will start working. So what you can do is set here 0, and that's it. And then again click on set button, then here's LOP, which is loop. So you have to keep it on infinite by these dashes here, or you can set the loop, like how many times you want to repeat it, so you can go with infinite. And then you can just long press the set button, and there you go. Now it's 360 minutes right here, and it's set for 360 minutes. Now there you go, here's work. Now it's W1209 temperature controller. So after like 360 minutes is done by right now it's only 1 minute is completed. This thing and the blower fan will be shut down automatically, so don't have to worry about like setting the time, then you have to wake up from your sleep and shut down this machine. Well, you don't have to do that. So now here it's time to set some temperature. So this is set button, this is up and down button. So long press on set button, keep on, then you get a lot of modes. So this is from P0 to P6. So what you have to do is to go to P2, so up and down button. And now here you can set the temperature. Right now I've set it on 80 degrees Celsius. Remember, this is your bed temperature. So what happens is, it will take little bit of time to spread the heat in whole chamber. So you might not see the exact same temperature as your heat bed temperature on the moisture and temperature model that you have put on top of this filament dryer. So long press on set button, and then go to P2, and then click set, and here you can change the temperature. So I'm going with like 80 degrees Celsius, which I have set. So once done, long press on set button, and there you go. Now temperature is increasing. It is very simple thing. If you haven't understood it properly, watch it again. If you still have the problem, comment down below. I'm willing to reply every single comment regarding this thing, because I found like quite complex. It took me like 1 hour to learn this whole system, and why it took more than 2 hours. And special thanks to ChatGPT to helping me out with this wiring, because there was no guide online.
regarding the wiring of this whole model, which is quite easy and complex at the same point of time. So that's it. You can see the machine behind me, and it's been like 7 hours since I put my PET filament. So let's open it and see how this thing is going on. It's time to open the treasure. So let me just unscrew one side. So before unscrewing the other side, you can see here is showing 41.6 degrees Celsius because it's just closed now, and 19% humid temperature, which I think is probably incorrect, because the thing is, this type of module, it comes with a external thermostat or whatever you want to call it to detect the moisture, and the temperature is enclosed into a plastic box, which I think basically used for the water temperature thing. So I think the reading for the temperature should be much higher. It should be more than like 60 degrees Celsius, but it is quite less, so I have to like change this module. So go with the one with the exposed thermostat, like the one comes with a bed and all. So go with that one instead of this one. I would highly recommend that. So let's just unscrew this one, which is quite noisy. So there we go. So this is our spool of filament. It's a green PET wire, agriculture wire, and spool is quite hot, bed is quite hot, and let me just put my face in this. And I can smell the heat inside, and it is like quite hot inside outside. So let me just take out this spool of filament like this, and there you go. Here I have the spool of filament. Now it's time to put for 3D printing before it start absorbing the moisture. So let's just do that. Problem is, if I take out this PET wire, it's gonna absorb the moisture. So I have to again put this thing on, set the temperature, and then a lot of electricity consumption. So for that, I gave you the holes which I covered with the tape right here. So if I remove that, you can see there is a hole through which you can take out your filament. So there will be very less chances, of the probability of absorbing the moisture will drastically decrease. So I'm gonna do that, and also given the pocket slide there in which you can put the silica gel. There are some packets of silica gel. Let me just put into these pockets, and there you go, done. So now we have silica gel, or whatever you call it, inside this. Now I have to just take out this filament reel from here. So everything was going right actually, and it was printing pretty well. I will show you the rest of the print, but eventually it failed, and the reason was, so the silicone cover came out while printing, and the reason was, let me just show it to you. I have to like zoom it. You can see the nozzle started leaking like this, and then the layer shift happened and it just failed. So I have to like tidy it again. I have to clean it. Now there's a lot of mess I have to do. But before that, let me just show it to you the rest of the print, how the print quality is in comparison to my previous video in which I printed the same benchy like that. So there you go. If you look at the rest of the print before it got failed, but there was a little bit stringing because I've increased the flow rate, which I shouldn't have done that. But look at this. So if you're wondering, these sparkle, well, these are not bubble. It looks like a sparkled filament. I don't know why. And it's like really smooth finishing and really good texture. I don't know. I'm seeing my camera, and I think it's not giving a clear picture, but it's like super clean and super awesome. There are a little bit color change in between, but that's okay. I dried the filament for like 6 hours only at 50 degrees Celsius, which was not that high for the PET filament. I have to dry it according to the PET G, which should be like 7 hours at 80 to 85 degrees Celsius, I believe. But this is like the first print. Then look at the before, which I did that, and texture is rough and it is super bad. This print is from my previous video, and this also got failed, but this got failed because of the nozzle fog, not because of leakage of filament. And the print quality is super rough. You can see, if I compare it, if I put both of the benches side by side, you can clearly see the picture here. You can see the print quality different before drying and after drying the filament. Well, actually it's not a filament, it's actually a agriculture wire. So if you dry the filament, you will get much better quality. And this is agriculture wire, which is not for 3D printing purposes, but after drying it just double X or 10x the result. So I think it's pretty good. Here you go. This filament dryer is super awesome and super worthy. I thought it will be like inferior to the industrial grade or the one that is manufactured by big companies, a company like Eason or many of the 3D printing companies which also manufacture the filament dryer, but it's like standing side by side. I need to do more testing regarding getting the exact number, but which I'll do it again. But I mean, drying that agriculture wire, I think this is like the ultimate proof you could have that your filament dryer is working and it is working insanely well. So if you're wondering how much this cost me in order to make, so excluding the cost of the time, obviously, because time is money, some says, but I think time is more important than the money. So apart from the philosophy, I would say, excluding the time and the electricity bill, which I believe your father pays. So I don't know how much the electricity it has costed. So if you're considering the filament and all the components I use and the wires and every single thing, it costed me around $36. So this cost me $36 to make this thing and 45 to 50 hours of printing. I think which is really worthy, given that it is like cheaper than most of the filament dryer in the market, and you can put 4 spools of filament at a single point of time. And if you want to use it at dry box, you can put 3 spools of filament and take out the filament through those holes and put it in your 3D printer. I think this is amazing, I would say. And prices vary from place to place. The component might cost you more or less, but I've told you the price which costed me. So that's it for today's video. So if you like this, hit the like button. Do subscribe. If you want the STL file, you can check the description down below. That's it. Goodbye.